All right, so today we're going to take a look at finding critical values, or sometimes called critical numbers. Critical values are when we take a derivative and set it equal to 0. The value, that x value that you're getting, is what we call our critical value, or again, critical number. So as you guys saw last week, if the derivative is positive, it means the graph is increasing. If the derivative is negative, it means the graph is decreasing. But what we're going to focus on today is those critical values. So those values where the graph is either 0 or undefined. Those are two instances of critical values. So let's take a quick look at an example. All I want you guys to do today is just find these critical values. So we're finding the derivative and setting equal to 0. Now, if we take a look, I have the graph just here for us to take a look at after the fact. But if we find the critical value or values for the function f of x equals x cubed minus 12x, first thing we need to do, we need to find that derivative. We need to find out what f prime of x is. So f prime of x is going to be 3x squared minus 12. And then to find those critical values, what we need to do is set this equal to 0. So we're going to say 0 is equal to 3x squared minus 12, and then go ahead and solve. So we'll factor, I'm going to factor out that 3. So we have 3 and then x squared minus 4. And then we can factor that further. We have x plus 2, x minus 2 at the difference of two squares. That equals 0. So we know that there are two x values. We have one where x is equal to -2, one where x is equal to 2. Those are two critical numbers, or two critical values. Now what's important about those is, let's take a look on the graph. On the graph right here at -2, what does it show us? It shows us a slope of 0. So at -2, we have that slope of 0. And the same thing over here at +2. If we follow down for the +2, we see at that point there's a slope of 0. Now what's important about these critical values is it can be, it doesn't have to be, but it can be the point where we see a graph go from increasing to decreasing. Now I just say it can be because we'll see some instances in the future where maybe it'll just kind of level out for a second and then continue increasing. But for today, you can see we have an increasing graph from the left. Whoops, let's go backwards here. An increasing graph from the left. Then it goes to 0 at that critical point, then it's decreasing again, and then all of a sudden we get that another critical point, and then it's increasing again. So we'll have more of a conversation about that this week, but that's what we're taking a look at for today, finding critical values or critical